Hello students, welcome to Physics CT online classes. In today's class, we are going to have the discussion on the continuation of the current electricity. In the last class, we saw some techniques or the shortcut methods how to solve the complex circuits. So we'll see some more examples on that. So few problems related to that, and we are going to wind up the topic current electricity. So first we'll discuss with one problem that we are going to take it as the equivalent resistance, the equivalent resistance, the equivalent resistance of the circuit, the equivalent resistance of the circuit between A and B. Between A and B is they are given the options 30 ohm, 20 ohm, 10 ohm, 80 by 6 ohm. Okay, so the circuit they are given like this. The resistor, you have one more resistor and you have another resistor. Okay, so from here to here we have one resistor. Again from here to here we have another resistor. I have taken this both as A, B. Okay, so they given the values here as 10 ohm, 20 ohm, 30 ohm, 10 ohm, and 20 ohm. Okay, so these are the things they are given now. So now, if I want to solve this, just I'm going to give the naming. This already it is A. Okay, again I'm going to give this as C and this as D. I'm going to redraw this circuit in my convenient way. So I'm going to place the 4 points. Okay, I'm going to place the 4 points. So I'm going to take this as A and this as B. Okay, from this is C and this is D. So A to C you have one resistor. Okay, again from C to D you have one more resistor. D to B you have one more resistor. Next from D to C you have one more. B to C you have one more resistor. A to D you have one resistor. Okay, so from A to C it is 20, correct? The C to B is 20. Uh, B to D is 10. Okay, A to D 10. So C to D is 30. You can see here 20 by 10 is equal to 20 by 10. Then it is balanced network. So balanced network. Now since it is balanced, you can eliminate this resistor. Okay, so now this both are connected in. So you can remove this one. So this both are connected in series. So it is 40 ohm. This both are connected in series. It is 20 ohm. So 1 by 40 plus 1 by 20. So 40 into 20 divided by 40 plus 40. So 40 plus 20. So 40 into 20 divided by 60. So it is mm, so the so it is in the terms of 80 by 60. So finally it is 80 by 60. 0 cancels the what is the 80. So option D is the right answer. I hope you are clear with this, right? Okay. So you can just copy down this. Okay, we have one more problem here. The value of I in the figure, the value of I in the figure shown below, shown below is, so option A 21 ampere, option B 19 ampere, option C 4 ampere, option D 8 ampere. So this is the circuit diagram. Here they given us 20 ampere. Here they given us 5 ampere. Here it is 3 ampere. Here it is 1 ampere. So here they given 4 ampere. Okay, now you can see here we have 1, 2, 3, 4. So 4 points we have. Now you observe here when it comes at this particular point, 20 is been entering and 5 is been leaving. So the current across this will be 15, right? ಯಾಕಂದ್ರೆ 20 minus 5 will be 15 will pass ಆಗುತ್ತೆ. Now 14, 4 is been entering, 15 is also entering. So here it will be 19 ampere. Here the 5 is been entering, 3 is been leaving. So here it is 2 ampere. So 19 is also entering, 2 ampere is also entering at this particular point, and you have already 1. So all are in leaving. So 19, 20. So hmm, so here the problem is I ampere. Okay, here they given I. We have to find the I. So 19, 21. So total it is 21 ampere. In the same way, we'll see one more problem, the same kind but different way. So here they given one line. So here the options are given as 1.3 ampere, 1 ampere, 1.7 ampere, 1 3.7 ampere. Okay, now the current across this 2 is also entering, 2 is also entering, so it is 4 ampere. When I come through this particular point, one is leaving, so it is 3 ampere. When it comes at this particular point, so it will be 14.3. So 4.3 ampere. Here at this particular point, one has been leaving, one I3 has been leaving. Both are leaving. Okay. So when you solve, finally you'll get the answer as 1.7 ampere. 1.7 ampere. I hope you are clear with this, right? Okay. Hmm. So we have one more problem. The equivalent, the equivalent resistance, the equivalent resistance between the points, between the points P and Q in the network, P and Q in the network shown in the figure. So option A is 2.5 ohm, option B is 7.5 ohm, option C is 10 ohm, option D is 12.5 ohm. Now the circuit they given like this. So this is P and Q. So they given this as 5 ohm, 30 ohm, 10 ohm, 10 ohm, 5 ohm. I'm going to stretch this P and Q. I'm going to stretch this P and Q. Then I'm going to draw the circuit as this is Q and this is P. So middle one will be 30, 10, 10, 5, 5. So since it is a balanced network, this part will be eliminated. 10 plus 5, 15, again 10 plus 5, 15. So 1 by 1500, So 15 by 2. So final answer will be 7.5 ohm. So option C. Option C. Okay. Next, Kirchhoff's law are applicable for Kirchhoff's Kirchhoff's laws are applicable for DC circuit only, AC circuit only, both AC and DC, either current circuits nor direct circuits. So today we are done with that only. So based on that, the Kirchhoff's law are applicable for both AC and DC circuits. So please remember with that. Okay. So please concentrate on dimensions also. That is also very, very important thing. Okay, dimensions in the first year topic ಅಲ್ಲಿ ಯಾವುದು dimensional formulas ಎಲ್ಲ ಓದಿದ್ವಲ್ಲ ಅದೆಲ್ಲ ಸ್ವಲ್ಪ ನೀಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. Okay, so the next problem, taking the internal resistance, taking the internal resistance taking the internal resistance so taking the internal resistance of the taking the internal resistance of the battery, taking the internal resistance of the battery, internal resistance of the battery as negligible. So we are going to neglect that. So we are going to negligible. The steady current, the steady state, the steady state current, the steady state current in the 2 ohm, in the 2 ohm resistor, the 2 ohm resistor shown in figure, shown in figure. Okay, so we have the resistor here. Along with that, we have one capacitor. So we have the cell. So please make the differences. This is capacitor C and this is battery. Okay. So it is 2 ohm resistor, 3 ohm resistor, 6 ohm resistor, 2.8 ohm resistor, say 6 volt we have. So options is 1.8 ampere, 2.9 ampere, 2.9 ampere, 0.9 ampere, 2.8 ampere. Okay. Since no current flows through 6 ohm resistor, around this we don't have any current will be flowing. as capacitor offers infinite resistance to the DC source. So you can say here the complete thing will be blocked. So this is not used. Now these two are connected in parallel. Okay. So I can write this as R is equal to 2 into 3 divided by 2 plus 3. So it is 6 divided by 5 ohms. Okay. So now current I is equal to E divided by E divided by RH. Current drawn by the battery we are going to consider. So the steady current across the thing. So you have to find the current across the 2 ohm resistor. Now you can say this before I go with the total current. Before I go with the total current. Now you can see after solving this we'll get one resistor that is connected in series. So I can write it as 6.5 can be written as 1.2. So 1.2 plus 2.8 is equal to 2.8 nothing but so 4 ohms. Now this will be the total resistance. So I'll take this as R dash. R dash is total resistance. So E divided by R dash. E is 6 divided by 4. So 3 twos are 2 twos are. So then it is 1.5 ampere is the total current. Okay, now I have to find the potential difference across that sense. Okay, so the potential difference across A and B. Why? Because this is nothing but either A and B. We have to know that if I know the potential across this combination, then I can find the current individually. So potential V is equal to I into R dash. I into R ಅಂತ ತಗೊಂತೀನಿ. R is nothing but ಇದೆರಡು parallel ಅಲ್ಲ. So when you solve this in parallel, you can say I is 1.5 into 1.5 into 1.2. So when you solve, you'll get 1.8. Okay, 1.8 volt. Now across 2 ohm, it is 1.8 divided by 2. Okay, 1.8 divided by 2. So it's nothing but 0.9 ampere. That is the current. So option C is the right answer. Okay. Okay. So we have one more problem. I hope you are clear with this, right? You can just copy it on this fast. Okay. So next problem, to get maximum maximum current maximum current in a resistance, maximum current in a resistance of 3 ohm, one can use one can use n rows of m cells. Okay, so it is connected in series, connected in series, again connected in parallel. Okay, it is connected in series and parallel. If the total, if the total number of cells is 24 and the internal resistance the internal resistance of a cell is 0.5 ohm, 0.5 ohm, then so option A they given n is equal to 12 comma n is equal to 2. So option B, n is equal to 8, n is equal to 3. Option C, n is equal to 2, n is equal to 12. Option D, n is equal to 6, n is equal to 4. So here we can see we can connect 24 cells in n rows of n cells. Then if I is the current in the external circuit, then you have the formula I is equal to ME divided by MR by N in R. Okay, so I will be calling this as equation 1. So for I to be maximum, okay, so MR plus NR should be minimum, should be minimum. So should be minimum. So it is minimum for R is equal to M by R divided by N. So the current in the external circuit will be maximum. So I can write I is equal to ME divided by 2R. ME divided by 2R. So this is equation 2 and this is equation 3. Here we can say they given R is equal to 3 ohm and small letter r is equal to 0.5 ohm. 0.5 ohm. Now, so equation 2 becomes, see here, in equation 2, I can write m by n is equal to r by 2. So 3 divided by, so 3 divided by 0.5. So 1 by 2 anta tagomತೀನಿ. So it is nothing but 6. So m by n is equal to 6 ಆದರೆ, so we can say that n is 2, n is 12. Okay, that's it. Just pop it on that. Okay, so just pop it on that. Okay, the next problem, if the points A and B are the same potential then x equals, so option A is 0, option B is 4 ohm, option C is 8 ohm, option D is 24 ohm. Okay, the circuit they given like this. It is x 12, 27, 9. Here it is 10. Okay, since they have told same potential, okay, it is same potential at E and B. Since it is same potential, you can just neglect it. So current through the 10 ohm resistor will be 0. So electrically you can say it is balanced. So you can just write that as x by 9 is equal to 12 by 27. So x is equal to 12 by 27 into 9. So if you solve that, you will get 4 ohms. So option B. So I hope you are clear with this concepts. Okay, so the current electricity is very important. So still you do lot of problems, work out with that. So definitely you can do it well. So thank you all. We'll meet in the next session with a new topic. Thank you all. Have a great day.